Here we go. In this video, we're going to learn about Bellmanford algorithm. So we have directed weighted graph. So we need to find shortest distance from source. So this thing we can also do with Dijkstra algorithm. But a drawback of Dijkstra algorithm is it does not work for negative edges. But Bellman-Ford will work for negative edges. We have negative edges. So first application is this. Next application, it will detect if there's a negative cycle. So I will talk about it. What is a negative cycle? So let me erase this and let's jump to the problem. What we have? So this is a problem. You are given a weighted directed graph of v vertices and edges. We need to find the shortest distance of all the vertices from the source vertex SRC. We need to return in a list format where the ith integer denotes the distance of the ith node, okay, from the source. If a vertex cannot reach it, then just mark it with 10 raised to power 8. If the graph contains a negative cycle, just return -1. So this question will fulfill both our application. So we have this. So starting from 0 to itself, the distance is 9. 0 to 1 is 9. 0 to 0, 0 to 0, the distance is 0. Then 0 to 1, the distance is 9. Then from 0 to 0, actually in this case the source is 2. So let's start from 2. From 2 to 0. From 2 to 0, we got 1. From 2 to 1, what we got? We got 6. So that's why we have filled 6. Then for 2 itself, we got 0. So that's about it. Now let's try to understand what's a Bellman-Ford algorithm. Before that, I hope you have a clear understanding about Dijkstra algorithm. If you don't know Dijkstra algorithm, just watch the video, then come over to this section, then come over to this video. So this is a graph, and before going into the algorithm, let me tell you what's the difference between negative edge and a negative cycle. So we got this and there's a cycle. What about negative cycle? So we have this -2, -4, then here we got 4. What's the total of this cycle? -2, -4 and 4, -2. So it's a negative cycle. If we start from this, then we go to negative. If we go to here, then we again go negative, then we again go negative, then we again go negative. So we are stuck in a loop. So it's a negative loop we are stuck in. So that's why it's a negative cycle. If we just convert this value, then we got positive 2. So now it's a positive cycle. So we can easily reach one vertex to another vertex. So that's the difference between negative cycle and negative edge. Here we have some cycles. This is a cycle, but this is a positive cycle. Then yeah, we have only one cycle here. Actually one more cycle, this cycle. So this cycle is also positive, so we don't have to worry. Now let's try to understand what Bellman-Ford algorithm is. We have a source. Let's take source as 3. So then what we'll do, we need to fill an array 0 1 2 3 4 5 6 7. Actually 0 1 2 3 4 5 6 4 5, we only need 5. So in the problem it is given that initially all values is 10 raised to power 8. So I will just fill that value. For simplicity, I am filling infinity. Then to start from 3, to reach 3 itself, we need to first fill 0. Then what we got? If you look at the function, in the function, what we are getting? We are getting edges. So Bellman-Ford will work on edges, not on adjacency list. So we have edges. So let me write edges here. You can just skip this part if you don't want to see. So 0 to 1, actually 0 to 2 with minus 2, 0 to 3 with minus 4. Then what we have, let me write this. So here we have edges. So starting from 2 to reach, starting from 0 to reach 2, so we cannot reach 0 now, but we reach it afterwards. But now we cannot reach 0, so the value present in 0 is infinity, so we simply ignore just now. Then again we have 0, again we have infinity, we cannot reach the 0 now. So then we have 1, yet we have not reached 1. So 2, we have not reached 2. Then again 2, we have not reached 2. Then 2, we have not reached 2. Then 3. So 3, we have reached 3. So from 3 to 1. So we are going from 3 to 1. So what we got? We got 2 here, and to reach 3, to reach 3, we got 0. Then to reach 1, we got 2. We have to traverse 2 distance. So we will just fill this value. We need to fill the minimum value to reach 1. What we fill? We just fill 2. Then we have one more edge from 3. So from 3 to 5, 3 to 5, what's the distance uh, we have to carry? So starting from 3, we have 0, but to reach 5 we have to take minus 4. So the value stored in the edges list, from 3 to 5 we have to bear minus 4 cost. So we will just fill minus 4. So we have visited this one time. So let me write one time we have visited this, and also write number of nodes. So v, number of nodes is 6. We need to do this for v minus 1 times. Why v minus 1 times? I will tell you. I will tell you why we need to do v minus 1 times. So just now we have traversed for one time. Let's do the iteration for one more time. From 0 to 2, 0 we have not reached yet. 0 to 3, we have not reached the 0. From 1 to 1 to 0, 1 to 0. Yes, we will go from 1 to 0. To reach 1, we have to take 2. Then further we are going from 1 to 0. So we have come from this path, then this path. So to reach 1, we have to carry 2. Then again to reach 0, we have to carry 5. So in total cost to reach 0, this plus this value. So to reach 0, we need to take 7. So we will just fill 7. Then we are done till now. So let's talk about this. 2, we have not reached 2. So this 3 will just skip out. Then 3 to 1. 3 to 1. To reach 3, we have to cost 0. Then 2 more. So to reach 1, we have to take 2. 2 is already present, so no need to worry. Then to reach 5, we need to take minus 4. So 0, actually 0 plus minus 4. Minus 4 is already there, so we don't have to worry. Then we have done this for 2 times. Let's do it for one more time. 0 to 2, 0 to 2. To reach 0, we have to take 7. Then to reach 2, we have to take minus 2 cost also. So the total cost will be 5. So we have to take 5. Then we have 0 to 3. 0 to 3. We have minus 4 cost. Then to reach 0, we have 7 cost. The total cost will be 3. But minimum value is there, so we will not update our 3. Then 1 to 0. 2 plus 5, 7. 7 is already there, no need to worry. 2 to 3. Okay. 5 plus 8, 13. No need to worry. 2 to 4. 1 plus 2 is equal to 5. So just update this with 5. So 2 to 4 is done. Then 2 to 5. 2 to 5. 5 plus 7 is 12. So already smaller values there. Then 3 to 1. 3 to 1. 2 plus 0. 2 plus 0. So what we got? We got 2. So I think I have made a mistake. So let me undo this. 3 to 1. Okay. No, no, no. So we have 3 to 1. But this I am pointing to 0. So we have 3 to 1. So 1 is this 0. Then 2. So the total cost will be 2. 2 is already there. Then 3 to 5. Minus 4 plus 4 plus 0, which be minus 4. So minus 4 is already there. No need to worry. Third iteration is also done. Next, one more iteration. 0 to 0 to 2. Total cost will be to reach 0. Then to reach is further 5. So no need to worry. Then this 0 to 3. 7 plus minus 4, which equal to 3. So negative value is also there. No need to worry. Then we have this 1 to 0. 2 plus 5, 7. 7 is already there. Or less than or equal to is already there. Then 2 to 3. 5 plus 8, 13. 13 is 13 we will not update. Then 2 to 4. This value plus this value 6. So we will not take this path. Then 2 to 5. This path plus this path 12. So we will not update this. So then this will not update, this will not update, as we have already checked. So then fourth iteration is done. It's time for last iteration. 0 to 2. 7 plus minus 2 5. No, we will not update. 0 to 3. 7 plus minus 4. 3 will not update. 1 to 0. This and this 7. 7 is already there. Then 2 to 3. This value plus this value 13. So smaller value is already there. 2 to 4. 5 plus 1 6. Smaller value is already there. Then 2 to 5. This value plus this value 12. Smaller value is already there. Then this and this also done. So we have done v minus 1 iterations. This is the minimum distance starting from 3. As you can check, if we start from this to reach 3 we have 0. Then to reach 0 we will follow this path. Total cost is 7. Then to reach 1, to reach 1 we will traverse this path. Okay, okay, so it will just undo. I don't know what happened. So I have path here, so it will just work fine. So then let's find out why we need to do v minus 1 iterations. So let's assume our graph is like this. Actually this is a zero based indexing, so let me add 0 here. So minus 2, 2 minus 4 and 16, any random weight, any random weight. So let's suppose we have source as 0. So to reach 0 itself we have this, then this, then this, then this. Then to reach this we go to this, we go to this. Before that, no, I will not take 0, I will take 1. So no, let's take 0, then I will tell you why we need to take 1 also. So this, there is a edge case. So first let's start with this. So we have 0 to 1 with minus 2, 1 to 2 with 2, 2 to 3 with minus 4, 3 to 4 with 16. So first it will only update this. Actually the order is the most important thing. The input edges array order is the important thing. So with 0 1, then minus 2, then 1 2 with 2, 2 3 with minus 4, 3 4 with 16. So first we have this, it will not change, it will not change, it will not change, it will change. So from 0 to 1 it will change, the value will be minus 2. Until now we have done one iteration. and we have just reached here. We need to reach till the last node. So uh, we have uh, we have 5, so we need to do one iteration, then two iteration, three iteration, then four iterations. So that's why v minus one iterations we have to perform. V minus one iteration we have to perform. So after that, only then this value and this value, each and every value contains the amount to reach that particular index. So I was talking about, let's suppose we take 1. The starting index given is 1. So this is a edge case. Starting index is 1. So what we got? Infinity, 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 0 and infinity. So this will not work, this will not work, this will work. So let me first change the order just for simplicity, so we don't have to traverse for v minus 1 times. Just for simplicity, 0 to 1 minus 2, 1 to 2 2, 2 to 3 minus 4, 3 to 4 16. So ordering is the most important thing, the input order matters. So then we got this, so it will not change because we have not reached 0. Then we have 1 to 2, so it will change and the value will be minus 2. Sorry, 1 to 2 the value will be 2, 1 to 2 the value will be 2, then 2 to 3 the value will be minus 4 plus 2, so which is minus 2. From this to this the value will be minus 2. Then to reach 3 to 4 we need to take 16. 16 plus to reach starting node, 16 minus 2 14. So 14. Just assume we have done v minus 1 iterations and this is the answer array. Then we need to do one more step. We need to do one more step. Why we need to do one more step? So if there's a cycle, it will detect a cycle. How it will detect a cycle? So let's assume we have this. So this is zero based indexing. So let me take 0. So this is our array. Minus 2, minus 4, minus 1. So that's a negative cycle. And we have to do for v minus 1 iterations. So 0, 1, 2. Starting node, let's say 0. So 0, infinity, infinity. As is given is 0 to 1, 0 to 2, 0 to 2 with 4, then 2 to 1 with minus 1, then 1 to 0 with minus 2. So it will perform. Then we have minus 4 here, then 2 to 1. It will not work. 1 to 0. Uh, okay, so from 1 to 0. Yeah, from 1 to 0 we can go, and the value will be minus 2 plus minus 4, so it will be minus 6. So we have done this iteration for one time. So what's the v here is 3, so we have to do one more time. So let's do one more time. So from 0 to 2, 0 to 2, minus 6 plus minus 4. uh, okay, so I think, okay, so we got 0. So starting index is our starting index is 0. So 0 to 2. So I think I have made a mistake here. Yeah, I have made a mistake. So let's continue. Let's restart. Our starting index is 0. So from 0 to 2, the cost will be minus 4. So to reach 0, we have this. Then we got minus 4. Then to reach 2 to 1, 2 to 1, we have to bear this, then bear this. So what we got? Minus 5. Yeah. Then 1 to 0, 1 to 0, minus 2 plus minus 5, so it will be minus 7. As you can see, we have updated our starting point. So we have updated our starting point. So we have done for one iteration, and we have v as 3. We have to do this for v minus 1, means 2 iterations. So let's do it for one more iteration. So from 0 to 2, 0 to 2, this value plus this value, so it will be minus 11. Then 2 to 1, so what's the value for 2 to 1? Minus 1 is there, then minus 11 is there, so it will be minus 12. So here we have minus 11, and for 1 we have minus 12. Then for 1 to 0, 1 to 0, this value plus this value, so it will be minus 14, minus 14. So we have do this for 2 iterations. So if there's a regular graph, if there's a uh, negative cycle is not there, so it will give me answer. But in this case negative cycle is there, so how do we detect? If I do this iteration one more time, if I do the iteration for one more time, we have 0 to 2 with minus 4, 2 to 1 with minus 1, 1 to 0 with minus 2. So if I do this iteration for one more time and any of this value change, then we will detect there's a negative cycle, because it will change the value only if negative value is present. We are changing the distance only and only if negative value is there. If there's a regular graph, v minus 1 iteration will just work fine, as I've shown you um, here. So in this graph v minus 1 iteration will just work fine. In any of the graph this will work fine, but for negative cycle it will again change the value. So let's find out. So from 0 to 2, 0 to 2, minus 12 plus minus 4, it will be minus 16. So again it is decreasing the value, it is decreasing the value again. But this is a not regular graph, so this is a negative cycle. We just need to return minus 1. So that's about this. And in this case we have 0 to 1. So um, I've talked about this case, and I want to tell you something. That's a special case from 0 to 1. If we cannot reach 0, then we cannot reach 1. This edge we will just skip, because this is our starting point and we cannot go before that. So if we cannot before that, there is a valid graph, no negative cycle is there, and it will just work fine. We will only compare it if the value is present from u to v. If value is present at u, so let's say answer of u, if there's a value present there, only then we will check for cycle. In this case we have infinity or 10 raised to power 8, we will not check it. So let me show you the code, then you will have a clear understanding. We have distance. First we will fill it with the description value, then for the starting value we'll just initialize. For v minus 1 times we have to iterate in the edges list. Then we have edge from u to v with weight. If we have not reached u till yet, we will just continue. Then we are at a node u, and if we take a distance to reach v, if we consider that particular path, and this path will give us smaller value, then we will update our value. Then we have to check for cycle. We will do one more iteration just to detect a cycle. So u to v, if this value uh, if the value is not infinity, so as I have shown you this, so you can just add this line here, but I have added it here. So you can choose whichever option you like. If we have not reached u, so how can we reach v? If we can reach u and there's a negative value, and if we want to reach v and we got negative value, so then just return negative minus 1, just return minus 1, means there's a cycle. Else we just need to return the distance. So let's give it a try, and let's talk about time and space complexity. So what do we have? We have edges list, and outside this we have v. So v and edges list. So let's find out. Yeah, edges. V cross E is our time complexity, and our space complexity just for distance, which is order of V. So it's a pretty straightforward algorithm. And I hope you've learned something new. Give this video a thumbs up, subscribe to this channel, and code is provided in the description box. Thank you all for watching.